Assalamualaikum warahmatullahi wabarakatuh, and very good morning. My name is Amir Yazid bin Ali, and I'm from Industry Science, Malaysia. In line with the conference theme, my topic will be today, approach to designing medical products. I have written several papers on designing medical products, and also I have made prototype during my years in University Science Malaysia. Okay, let us start by defining what is medical devices or medical product. The World Health Organization has defined medical devices or product as stated there in my slide, which is an instrument, apparatus, implements, machines, appliances, implant, reagent, software that is intended to use for human being and in the medical profession. Okay. The medical purpose for these medical devices are to diagnose, to investigate, to support or sustain life, to control, to disinfect, and also to provide information to the patient and to the doctors. Okay. Medical products are used by patients who are considered disabled, or they are used by doctors and nurses who are very, very busy, right? Very, very busy people. So then they cannot make mistakes. So for a medical device should have these 10 features of that must be included in the design. Okay, the first feature to be included is innovation. Okay. Innovation will improve how something is used, right? It also, an innovative product is always focused on something that is relatively new or seldom features that is not considered in other design. Innovative product is a must for any designers of medical product, because if not, they will infringe the copyright law. Okay, the second feature is usefulness. All product design in medical field should serve a purpose. The purpose can be to serve the patient, to serve the doctors, or all the medical frontliners. Okay, and the job, the product must serve the basic purpose. Right? There is a function of the job of the product, so it must serve that. Thirdly, aesthetics. Is human being. Human being like to see something nice, right? And when something is nice, we might try to use it, or we have a desire to consume it. So, if a medical product that it looks so rugged, it might not entice the user to use it. So, make it look nice. Fourthly, the product should be easily understood and is self-explanatory. The patient or the user or the doctors, they don't have to figure out how to use it. By looking at the product, they know. So basically, a lot of the design should be using stereotyping, right? The stereotyping thinking, and also does not have anything that is weird. Yeah, because the user might not know how to use the product. And fifth, the product should not deter the user from doing something else, right? It is useful for certain things, and it should not deter or the user from doing something else. For example, the product obstructs the user from eating. So I don't think that is a good design. So try to make it unobstructive. 6, the product should be honest, right? It should deliver what it is supposed to do, and it should comply with all the requirements in the medical field. Okay. There is a list of requirements stated by WHO on product design, required on the product, medical product. So comply to it. Okay. The product should be long-lasting or durable. It should not get broken while patients are using it. It should not be malfunction, right, while being used. And in the design, okay, the designer must be very detailed, okay? Try to look where failure can occur and try to combat that problem, okay? So very thorough. So you look at it, you see where it can fail and redesign it again so that it won't fail. So be very thorough in all the details. And of course, in this era, we're talking about environment. Make sure when the design is used, no hazardous material being used, right? If hazardous material is used, try to look at how to dispose it properly to the environment. If possible, use material that can be recyclable. So instead of using non-recyclable plastics, why not use environmentally friendly materials such as wood or something else, yeah, or metal. And lastly, last but not least, I say that the design should be pure and simple. Think of how to make it simple. Think how to use the least amount of material. Think on how to design it in such a way that it looks simple, it is simple, and it's easy to use. Okay, that's the most important thing here. It's easy to use. Okay. The following are 10 elements in the process of designing medical devices. Okay. The first step is to define the goal. Why are you designing it? Tell us the reason. Okay, your main objective of trying to design the medical device. Okay. The second step is to do some planning. Design needs planning, right? If not, it will go haywire and it will take a very, very long time to design a product. Thirdly, we should focus on the user first, right? Instead of the design, focus on the user. What does the user want? What does the user need? Okay? Don't design for the sake of design. Thirdly, fourth. product specification. Now, as an engineer, you should look what the product should have to meet the requirement of the user. Okay. So once you know the specification, so you develop the concept, how it should be, right? It should do what? How does it look like? What are the things that need to be done, right? What is key main features and or anything that is superfluous. So you have to consider all those. And because of that, you have to evaluate it, step. Yeah? After evaluation, you have to do the product design architecture. How are you going to do it? Is it supposed to be modular, or is it integral, or is it one piece or multiple pieces? Okay, that is how the architecture should be. That's how you should take care as a designer. And fourthly, you do detailed design. This is where you give the exact specification, the tolerancing, everything. Yeah, the GD&T. After that, you do a review. Have you done it all right? Everything is done. Have you missed something, right? Have you missed something? Some of the, when you go ask the user in the first place, have you missed something? You didn't ask a question. So this is the process. So if you look at there is a feedback system, right? So there is a feedback system in the process. We'll go back to the detail design, and so these things go in and forth. So if you look before, you have also a feedback between the concept evaluation and concept development. So if something, when you evaluate and you find out something is amiss, then you look back at the concept development. And everything in that picture goes from here. So there is a loop system in the design process. Okay, and the last one is prototyping, which means you make a sample of the product. So that there is many purposes of doing this. I will carry on, explain to you later on. The first design step is defining your goal. Okay, what is the goal of designing? So to answer that, basically you have to answer four W's and one H. The first, the W's are what, where, how, why, and who. Okay, so you try to answer those. So for example, this is what I did basically in my paper, canon paper, way back in 2008. This is my definition. What is my goal? Okay, to design an incubator for newborn infants at home in rural areas, yeah, in Kampong. We're using low technology because at that area they don't have electricity. And the reason is to reduce mortality rate of the infant and also reduce the problem of the mother, because these babies are actually they are having jaundice, which is critical for their life and death, right? The second stage is planning. You have to plan the design process, right? So there are 4 steps basically, four items that you have to do when planning. 1, select team members. The team members should have one person, at least one, that is a potential user. The reason is that he or she might give some feedback or how they will use it, the product that you have to be designed. The second is the gating event. Okay, where should you start and where you should stop in the design stage, right? Okay, you might start, okay, I want to start from process A until process B. So process B is the gating event. Then the next one will be, end of process B will be another gating event. So at each gating event, what you do, basically, before you move into this stage, you have to identify who is the users. Okay, users are basically the stakeholders of the product, which are of 1, the patients, 2, the medical frontliners, which include nurses and doctors and other employees. So, and the purpose of identifying the user's need is that we want to make sure that the product will be used by the user. But many design, whatever, not only medical products, but most products that is designed without considering the user always fail. Yeah, always fail if there is no consideration on the user. Before you move into this stage, you have to identify who is the users. Okay, users are basically the stakeholders of the product, which are of 1, the patients, 2, the medical frontliners. After knowing the customer's requirement, the next thing is to define product specification. Okay, the first thing before you define the product specification is to know what is the characteristic of the product that is needed. Right? So the first thing is to identify or establish what are the characteristics that is required. For example, an incubator, a baby incubator, should be large enough to place a baby. Okay, that is one characteristic. Or you can say the incubator should be heated up to a body temperature. That's one characteristic. So once you know the characteristics, okay, like you say, like what is the size of the incubator that you talk about? It should be around half a meter by 25 cm, right? So around that, so that most baby can be fitted in. So the dimension will be length, height, and volume. Okay? Height, length, and width, so the total volume of the incubator. So those are measurable things that we measure, can put a number to it. The next step is to set a list of metrics. Okay, what is metrics? Metrics is a list of our measurements. Okay? So when you talk about the dimension of the incubator, you give the measurement of the length, width, and height of the incubator. That's are the metrics. Or you talk about temperature, it should be more than 30 degrees C and less than 37 degrees C. Okay. Those are metrics. So we have a tolerance sometimes. The fourth is determining the values. Okay. What are the values of this metric? Before this, I told you that you need to put numbers, right? Okay, now you need it to be exact. 35.5 cm, for example, right? Okay, and the fifth, of course, all these things, all you have from step 1 to step 4, record it, put it into your document, right? What is to be done, or whatever characteristic that and its sub-characteristics must be documented. Yeah? And of course, put values to it. The next step is concept development. This is a phase where you want to get as many ideas as possible so that you can incorporate into the design of the product. There are 6 steps altogether, and the first step is, if you look at one of the characteristics of the product, then break it down and try to get as many and make a list of all the functions of that characteristics. Okay. Secondly, refer to other medical devices that have similar function of that character, or have that same similar characteristics. Then, how was the product, the existing product, works that can be used, that idea can be used for the new product. Thirdly, combine any other ideas that you have and with the existing product ideas, so that you can come up with many more ideas. Yeah. Create as many permutations as possible. Fourth, you create a list or generate a list of several alternatives to the design. The first 3 looks at the functionality. Now you look at the design. Yeah, I would suggest you use brainstorming technique, because it's quite common technique to be used. Fourthly, with all the ideas that you get from step 1, step 2, step 3, and step 4, you sort the ideas out, put in terms of priorities, then the best top ideas will be put it on the top, and if possible, you give points to each idea so that you can do some calculation on optimization and also on ideas selection. And lastly, emerge with a list of ideas to be implemented, which is the one that from the step 5. What you do, you take the 5 or 4 best ideas from there and try to incorporate into the design of the product. Concept evaluation. So, what do we need this? We want to know whether is it very important, or okay to have, or is not necessary but it's nice to have. So, or totally unnecessary. So we have to look at certain things, whether like the characteristics, so that, or some of the metrics, should it be very detailed, or to be exact, or the tolerance. Those are concept evaluations. So the first thing that we look is we have to look compared to what we aim for. For example, like the incubator, we aim to provide enough heat and enough ultraviolet light to the baby. Does that characteristics fulfill the requirement? So it just implies, so that we can make decision. Okay. Secondly, when we talk about concept evaluation, we try to eliminate the superfluous features that are not necessary, right? Because extra features means extra weight, extra cost, a lot of things that is unnecessary. So try to aim for the minimal part. Yeah. So there are two types of comparison. For example, you give a range, or you give an absolute number. Okay. Are you going to say, okay, let's say for the UV light, what are the range of the UV light wavelength? Of course, there is a certain wavelength there, right? So, or you want to give it an absolute number, because this might impact on the cost and also the level of difficulty in the design. This evaluation is very important because it will impact on the cost. And yeah. Secondly, what you do after you have what you want to compare, and then the next thing is how to evaluate it. So there are many techniques. So this is the most common. This is feasibility judgment, go/no-go screening, decision matrix, and AHP are most common techniques being used to evaluate concepts, design concepts. Yeah. Every product has several functional modules. Okay, so when you talk about product architecture, it's basically a combination or a collection of, and also the organization of all the functional modules and elements of a product we put together, and we want to see how they link between one and another. There are two types of product architecture. There is a product that is modular, which is actually consists of several components and will be assembled for operations. Another one is a single piece or integral product architecture, which actually only one piece. Yeah, so it will function by itself. Product architecture design basically has several steps. Basically, there are four steps in the design. The first step is to create the schematic of the product. Basically, we talk about drawing a schematic diagram of all the components of the device. Right? Secondly, what we do is we segregate the elements of the schematic or the components of the device, and then into several groups, and now we start drawing them in a geometric layout. And finally, you identify and the fundamentals of each component and each cluster of elements, and their step is detailed design, which is putting details to all the components and all the elements in the product design. Okay, this is actually getting into the nitty-gritty of things. Okay, what do we do? First, we check the design. Is the design or the element that we created comply with the safety requirement? Yeah. This is set by World Health Organization, the safety requirement. Secondly, you select the right material. What are the best material for the product? Okay, if the product requires to be light, then you choose light material. Right? If the product or the use of the product requires to be very strong, then you use material which is hard, which is very rigid. Okay. The next one is to reduce cost, right? And also to make it simplified so that we can actually produce it. we look at how it's going to be produced or going to be manufactured. Is it easy to manufacture? Because when we give a detailed design, for example, if our specs are very, very tight, then it's very difficult to manufacture. And the next one is we look at the cost. What is the way that we produce or the material that we select? Is there any cheaper alternative but still serve the same function? Check dimensions and tolerance in drawing. Okay. Do we need to be very precise? That's always the question. Do we need to be very precise, or do we have a certain range that it can work? What are the GD&T we are talking about? Yeah? So this is the criteria in the design. Fourthly, we look at the design itself in terms of ergonomic compliance. Is it suitable for human use? Will it make the usage of the design make people easy to use it? Or will the design be very confusing? And also, of course, we talk about aesthetics. Does the color match the requirement? The people? Do you think a pink will be suitable for men? That is aesthetics, yeah. And process review. This review must be done as a robust. The aim is to have a high quality standards in the product. Okay. So to do this review, first, the review must be done by experts, people who really know about product design and the usage of the product. Secondly, the reviewer must be a group of reviewer. Must be multidisciplinary. So they can be who can look at the technical aspect, the engineering aspect. The reviewer can also be a certain group of people who know really how to apply in the real world. And then and all these reviewers are honest and accountable to the people. And of course, there have to be a balance. We cannot have perfect in everything, right? So it must be proportionate. That is, of course, we aim to get the best of everything. But if you can do some balancing or optimization, that's good enough. Then the product must be able to be produced timely. So the process review must look at it, okay, with all these requirements that we imposed, can the product be produced timely and can it be used? All the above, all the previous steps are iterative, which means we have a feedback system, feedback to the user needs. So you can have to go back if there is any flaw in the steps. So finally, after doing all those, right, the next step is to do prototyping. What is prototyping? Prototyping is producing a 3D version of what you envisage in the design. Okay? It can be physical prototyping, which means you already produce a product, or either in actual size or miniaturized size, or you can do a simulation, a computer-aided drawing, for example, that is a three-dimensional. Okay. What are the general rules of prototyping invention? Okay, first you draw it, you then create a mock-up of the design.
Right.
Okay, so, but the whole idea is to have it in a three.
Open saya keluar dulu.
Okay. That's the end of my presentation today, and I would like to thank you for your attention, and I hope I don't bore you. Unfortunately, in this style of presentation, I cannot give you a question and answer session. But however, I hope that my presentation will spark out some new ideas,
Boleh.
also a new interest in the product design. Thank you very much.